Study the flow chart below and answer questions that follow. So let us start this flow chart together. So we can start even from here. This is a double bond, so it means this compound is an alkene. So if it is an alkene, we want to identify which alkene it is. So you do that by counting the number of carbon atoms in that compound. So here we have 1, 2, 3. Therefore, the number of carbons are 3, and then it is a double bond. Therefore, it is propene. This one is propene. If the number of carbons were 2, we call it ethene. If they were 4, butene. If they were 5, pentene. If it is a double bond. After identifying that, we can go to step 1. Step 1, we are they are adding nickel. There is hydrogen and then nickel catalyst. Nickel catalyst is represented by Ni. Ni stands for the nickel catalyst. So step 1, you can say that that one is hydrogenation. So the process here is hydrogenation. So step 1 is hydrogenation. Hydrogenation simply means addition of hydrogen. So when you add hydrogen to an alkene, you form an alkane. So J is 1, 2, 3, therefore it is propane. It is propane. Do you know how that happens? Let me do this something here. So we have propene, which is CH3, CH double bond, CH2, and then we are adding hydrogen. So what happens is that the double bond breaks. If the double bond breaks, we have 3 carbon atoms, so that's 1, 2, 3. Replace these hydrogens here. 1, 2, 3. This one and this one, 1. Here we have another 2. 1, 2. Now you see, each carbon is supposed to be surrounded with 4 covalent bonds. So here we are missing one carbon, one bond is missing here, another bond is missing here. Now this hydrogen breaks like this. One hydrogen attaches itself here, another one attaches itself here. And what is the name of this? 1, 2, 3. It is an alkane, because you can see it is a single bond everywhere. Therefore, this one is alkane, and there are 3 of them. It is propane. Propane. Step. Let us go to step 2. What is happening in step 2? Step 2. This we have found that this one is an alkane. Remember, alkanes, they do not react because they are saturated. Alkanes don't react because they are saturated. If they are saturated, therefore, and we are adding chlorine. What happens is that we have a substitution reaction. The substitution reaction. So alkanes undergo substitution reactions. So one hydrogen is replaced by one halogen here, so to form this compound here. So 1, 2, 3. This one is chloropropane. This one is chloropropane. 1 chloropropane. No, can I just say chloropropane? This compound here is chloropropane. Chloropropane. Let us go to step this addition of bromine water. When bromine water is added to an alkene, the bromine water, which is yellow, will be decolorized. It will be decolorized to form this compound here. So what happens is that, let me draw the structure. CH3, CH double bond, CH2. Bromine water, when it's dissolved in where this is now water, so it is HOBr. That's bromine water. That's how we represent bromine water. So what happens? The double bond breaks. We have this compound here. 1, 2, 3, 3 carbons. Replace the hydrogens there. 1, 1, 1. These 3. There is another 2 here. 1 here. Put it here. After the double bond which is broken here, we put the 2 hydrogens. So look at this compound. It is missing 1 covalent bond. 1 covalent bond is missing here. So the bromine water breaks to form BrOH. This is how bromine bonds are broken. So the bromine attaches itself either here or here. It is either bromine, and then the OH attaches itself here. And this compound M is called 1, 2. We can say 2 bromo. 2 bromo. 1, 2, 3 propanol. 2 bromo propanol, because we have 3 compounds. 1, 2, 3. Now this one, it becomes an alcohol, OH, propanol. Step 5. Step 5, we can see this one is a polymer. If this is a polymer, the step V is polymerization. Polymerization. 1, 2, 3. This is an alcohol, which is propanol. Propanol undergoes step 3 to form propene. So that one, this water is removed, therefore that is dehydration. You know the condition is set for dehydration: concentrated sulfuric acid, temperature of 160 to 180. Step 4, we are adding oxygen, therefore that is combustion, burning. So when alcohols burn, they give 2 products, carbon 2 and the water. Alcohol here is, we are adding sodium. Propanol plus sodium is going to form sodium propoxide plus hydrogen gas. So gas P is hydrogen. This one is called sodium propoxide. This is a salt, an organic salt. There is another step here downwards here which is not indicated. So it's to formation of Q, but we are adding an oxidizing agent. Acidified potassium permanganate dichromate is an oxidizing agent. So propanol will be oxidized to form Q, and the Q is propanoic acid, and the Q is propanoic acid. So this is how you analyze the flow chart in organic chem before even going to answer the questions. Now down the questions is that name substance J and draw its structure. We have already looked what is J. We have finished the J. J is propane. The structure of propane is simple as this. Put hydrogen. That is propane. And that is all. Next question is that what reagent conditions necessary for step 3? Step 3 is dehydration. Therefore, we know the reagent is concentrated sulfuric acid. Concentrated sulfuric acid. The condition is a temperature heat. Temperature of 160 degrees Celsius to 180 degrees Celsius. Step 2. Reagent required in step 2. Substitution will not occur if there is no the presence of light. So light is required. Therefore, The condition required in step 2 is UV light. For substitution to occur in alkanes, we need UV light. Name the following. L is carbon 4. Because you have been told to name, you give the name carbon 4 oxide. Carbon 4 oxide. Gas P. What was gas P? Gas P is hydrogen. Q is propanoic acid. Propanoic acid. M, where is M? M is here. M is called 2-propanol. 2-propanol. Next question is, write the equation for the reaction that occur in step 4. Step 4. So let us see step 4. Which one is that step 4? Step Roman 4. That is the combustion of ethanol, burning of ethanol. Is it not ethanol? Sorry, propanol. Propanol is C3H. So we can now condense this formula. 1, 2, 3. You write C3 like I have written. How many hydrogens? 3, 5, 7. H7 and then OH plus oxygen. They will give you this CO2 plus water. Because when you burn an organic compound, it will give you two products, which is carbon 4 and water. So we need to balance this equation. Let us make this carbon even. That is now 6 here. Hydrogen here now they are 14, 16. So we put 8 here to make them 16. Oxygen now here is 8 plus 12, that is 20. And we have 2 here. Therefore, we put 9 here. 9 times 2 is 18. 18 plus 2 is 20. This is liquid, gas, and this is liquid. Give the name of process in step 5. Step 5 is polymerization. But what type of polymerization? We have 2 types of polymerization: condensed polymerization and addition polymerization. Therefore, if you write polymerization alone, you will score nothing. Therefore, this one is addition. Addition polymerization. Next question is that if the relative molecular mass of R is this, calculate the value. So we have R is here 1, 2, 3, 4. So we have 4 carbons. That is 4 times 12 plus hydrogen is how many? 1, 2, 3, 4, 5, 6, 7, 8. So everything times n will give us 21,000. This is 4856, n equal to 21,000. You divide it by 56, this one will give you 375. The value of n is 375. N is 375.